All right. Welcome to chapter 9. We're week 8, chapter 9. We only have chapter 9 and chapter 10 left. So we are in the home stretch for sure. Some of the most useful, most fun stuff is in chapter 9 and 10. I know I say that every chapter, but it all kind of builds up to these two chapters. So today we're going to talk about point estimates for population proportion. We've already done that. But next we're going to do confidence intervals. And then after that, we're going to look at what is the sample size that we need in order to estimate a population proportion if we're looking for a specific margin of error. So that is what we're doing today. We're going to talk about margin of error and all of that. We're only going to deal with proportions. Lab 5, we will do instructions for that on Thursday because it deals with means, with confidence intervals for means. So I want to make sure I teach that before we go into before we do the lab for it. So Thursday, I will go over the lab, and it's our last lab of the term, and it's really not that difficult. It's a pretty quick lab to do because you're just going to use data you already have. So, so it works nicely. Find my iPad over here. Okay. So point estimate, we've done this before. It is a value, it's a value of a statistic that estimates a parameter. Remember, statistic refers to a sample, and parameter refers to a population. So just like before, we take the number of successes and divide it by the sample size. Then successes could just be how many individuals have a specific characteristic. And that is our p hat. We dealt with p hat in chapter 8. In fact, this particular 9.1 corresponds really well with 8.2. So a lot of the stuff from 8.2 will reemerge in 9.1. And then when we're in 9.2, it corresponds with 8.1. And I don't know why they did that. It annoys me, but it is what it is. All right. So once again, we're just going to find point estimate. Oh, I need my calculator. So a Quinnipiac poll asked 1,783 registered voters nationwide whether they favor or oppose the death penalty for persons convicted of murder. 1,123 were in favor. So we're just going to find our p hat. Anything that has a hat on it is an estimate. So our p hat is 1123 divided by 1783. And I'm going to put that in my calculator. You just watch. I'm going to swipe and it's going to already be there. All right. So we're at 0.6298. So about 63% of the people in this particular poll were in favor of the death penalty. That's it. That's our point estimate. We've done this before, not brand new. Is it there? See, it is. It's right there. Oh, well. The funny thing is, I looked at this morning, and this morning was when I edited it for this class, and still I forget the things are there. It is what it is. All right. So confidence interval. This is something that you have seen before, and you kind of know what it is. You just don't know that you know what it is. So it is an interval of numbers that we get based on a point estimate. It is a way that we estimate a parameter. So let me see if there's a better way. So basically, if I want to estimate the percent of people that are the percent of people that have dogs in their house, I can create a confidence interval by taking a sample, and then I would have like the number of people that have dogs in their house are about 58% plus or minus 3%. That gives me a confidence interval. And you've seen this in like polls and things like that, where it would say that a certain candidate they're estimating they have 43% of the vote plus or minus 5%. And that's what a confidence interval is. So if I say that so the level of confidence, it is the expected proportion of intervals that contain the parameters. So basically, if I took 100 different samples, If I was 95% confident that the population parameter was in my interval, if I took 100 samples, 95 of those samples would contain the actual parameter, the actual population, or actual proportion of people with that characteristic. So for example, once again, let's talk about dogs. So if I took 100 samples of 200 people, and I wanted to be 95% confident that I had the population proportion of people that have dogs. 95%, if I took 100 samples of, I don't remember the number I said, 200 people, 95 of my samples would contain the actual population proportion that have dogs. So obviously I can't interview the entire population. Let's do some examples and hopefully it'll help. Oh, see, look at this. 95% level of confidence, 100 different confidence intervals are constructed, each based on a different sample. We'd expect 95 to include the parameter. Remember, a parameter is something to do with the population. 5 would not include the parameter. Okay. So this is how we do our confidence intervals. We take our point estimate, then we calculate something called a margin of error. And you take your point estimate and you add the margin of error to it, and then you subtract the margin of error from it. That would give you the interval that we would estimate our parameter is in. We would estimate that our actual population proportion would be within the point estimate, adding the margin of error and subtracting the margin of error. And then we would have how accurate it is would depend on what our level of confidence is. And we'll go into all of that in a little bit. I forgot, I'm going to need my Z table. I forgot to unlock that. Hold on a second here. I need to open that up. Do I have that handy? I got to have that handy somewhere. I'm going to get it off of My Open Math because I know exactly where it is on My Open Math. I don't always like the Z table, but it is kind of helpful. Okay, there's my Z table. I will need it in a few minutes. So I'm going to open that up. All right. Let us jump into a little bit here. So here's a little bit of vocabulary and talking about what our margin of error depends on. So the first thing our margin of error depends on is our level of confidence. Our level of confidence is going to help us to calculate what that margin of error is going to be. As our confidence increases, our margin of error also has to increase. So if I have 99% confident, my interval is going to be larger, or my margin of error is going to be larger. The sample size. So if I have bigger sample sizes, my margin of error is going to be smaller. Bigger sample sizes are good because then it'll be a smaller margin of error. So our standard deviation of the population, if our population is super spread out, our confidence interval is going to also be spread out. It kind of makes sense because our population is all over the place. So these are the three things that our margin of error depends on. And the math that we're doing for margin of error and confidence intervals is not super different than what we've done before. Thank goodness. Right. So this is my little finger with the string on it. Remember, this is a recall. So remember that our population proportion, our mean sub p hat, we use the population proportion for that. And for standard deviation, we use square root of p times 1 minus p over n. And that is only if np times 1 minus p is greater than or equal to 10. Also, in order to decide that our trials are independent, our sample size has to be smaller than 5% of the population. So this is all the same stuff that we did in 8.2. Okay, this is how we calculate our margin of error. So our confidence intervals are always based on a center. So you may recall from previous ones where when I would say I would look for a probability and it would be like the center of our data. So I was looking for like the center 95%. I would have 2.5% up here, 2.5% down there. All of our confidence intervals are based on a center, on the center of our normal curve. Uh-oh. I'm missing things. There we go. So it's all going to be based on the center. Because of that, we have this right here. It's Z sub alpha divided by 2. So whatever our difference between 100% and our confidence interval is, we have to cut that in half. So for example, if I have a 95% confidence interval, then I do 1 minus 95% and I get 5%. So I have to cut this in half because half of that 5% is above my interval, half of that 5% is below my interval. So I would have to look for z-scores. That's what this is right here. I would have to look for a z-score for 0.975 or 0.025. So I would need to look for those because I'm the middle 95%. So what we do for our, let me erase this too. What we do for the margin of error is you take the z-score and you multiply it by the standard deviation. The z-score times the standard deviation gives you the edge of your confidence interval. And you do add that to p hat and then subtract that from p hat. Doggone it. So z-score times standard deviation, because this is standard deviation right here, is your margin of error. And it gives you the upper and lower bounds of your confidence interval. Don't worry, it's not as confusing as it sounds. Plus, you're going to get some fancy schmancy calculator functions because I love giving those calculator functions. All right. Let's actually do some math. Here's a good picture. I actually just took a picture of the textbook, got this directly out of the textbook because I like it. This is showing that I have the middle whatever percent and half of it is above. My alpha divided by 2 is above and alpha divided by 2 is below. Alpha is just the difference between your confidence level and 100%. That's all alpha is. I just thought this was a nice picture. Once we math it out, you got this. This right here is important because your textbook or your homework will call that. That doesn't help at all. Your textbook will call it a critical value. The z-score that we obtain for our confidence level is called a critical value. So the upper and lower bounds, or the z-score that gets us to the upper and lower bounds, those z-scores are called critical values. And it represents the number of standard deviations that we can be from the parameter and still result in an interval that includes it. You'll see. We got this. Okay.
Would you repeat what you said? Alpha is just the difference between...
Alpha, so alpha is the difference between our confidence level and 100%. So we take 100% and subtract our confidence level, then that's alpha.
Okay.
Okay.
Yeah, thanks.
You're welcome. So at the bottom of, I don't like this one, so I'm going to go down to the Z table. So here's the Z table. At the bottom of our Z table, scroll all the way down here, we have our most common critical values right here. These are not the only critical values, but these are the most common ones. And they already take into consideration that we are using the center 95% or the center 90%. They're already taking that into consideration. So if you are given any of these, for your confidence interval, your confidence level, these would be your critical values. If you are given something else, you can use inverse norm. And I will show you what that looks like. But these are like the common ones. So it's really nice if you just have your Z table in front of you. And then these, you can just look at these if it's one of these, the common ones. These are the most common intervals, even though I think your homework gives you a couple of wonky ones. But at the bottom of your Z table, so it's the front of that Z and T table, it gives you your most common ones. If I had something different, I would use inverse norm. And I'm going to show you that even without something different. I'm going to show you that when we do our calculations. Hey, look, it's right there. I didn't even need that open. Look at that. Okay. All right, here's the interpretation of our confidence interval. Let me tell you, they use a lot more words most of the time than you're going to need to use, but it's a nice, the conclusions are pretty good. So a confidence interval indicates that whatever percent of all simple random samples whose parameter is unknown will result. Now this, let's just not even do this. This is not even going to make sense. We're just going to ignore that. Just leave that alone. I already kind of explained it. Okay, let's actually map this out and this will help. July 2008 Quinnipiac poll asked 1,783 registered voters whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. We're going to get a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. Now, on our Z table, we have a 90% critical value or 90% confidence interval. It gives us a critical value of 1.645. I'm going to show you on the calculator. So since it's 90%, 100% minus 90% is 10%. So my alpha is 0.1 because that's 10%. We divide that in half because we're looking at the middle 90% of our normal curve. So I'm going to look at 0.95 with my inverse norm. So second, if it lets me, second vars, inverse norm, and I'm going to do 0.95. And then we're always looking at, Z scores. So it's just 0 and 1, because remember with a Z score, it's always at 0 and 1. Now, if you have the center on your inverse norm, you can put 0.9 up there for the area, but I just default to left because a lot of people don't have center. So just put 0.95. And look, it gives me that same value that we saw on our Z table. It rounds to 1.645. That is the same value that we just got. So if they give you something weird, every once in a while they decide to throw in like an 88% or something like that, you can just use inverse norm. Make sense? Any questions? Okay. All righty. So our point estimate, we already got that. We got that previously with 0.63. Don't worry, I am going to do one of these with me doing the math instead of it popping up on your screen. First thing we did determine was that NP times 1 minus P is greater than or equal to 10. It is a lot greater than 10. Ooh, that's a really weird pen. It's a lot greater than 10. It is at 415. So our sample size is definitely less than 5% of the whole population. Therefore, we can use our math here. Our alpha is 10%, as I stated before. So we divide that in half and we find the Z score that goes with the upper 5% of our normal curve. So we got 1.645. So now we're going to calculate the margin of error, which is this right here, the Z score times the new standard deviation. We're going to calculate that and we're going to subtract it from the mean, which is 0.63. We're going to subtract it from p hat. We're going to add it to p hat. So here we go. So this right here is p hat. This right here is my Z sub alpha divided by 2. That's what that is. That was an infinity. Ignore that, pretend that's an alpha. And then I have, since I don't have a population proportion, I have to use my p hat. So I have 0.63 times 1 minus 0.63 divided by my sample size, 1783, then take the square root. So the lower limit of my confidence interval is 0.61. The upper limit of my confidence interval is 0.65. So now I can be 90% sure that the actual population proportion of people who believe that the death penalty should be for people who murder is between 61% and 65%. I'm going to show you a couple of different ways to write this. You need a moment? Are we good? Okay. So I am 90% confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 65. Now, I would be okay if you said between 61% and 65%. The other way that we can write this is I could say 0.63 plus or minus 0.02, because this value is 0.02 below my p hat, and this one is 0.65 or 0.02 above my p hat. This right here is the margin of error. I have a 2% margin of error there. Questions before we do another example? All righty, let's do one where we actually do the math. So Gallup organization conducted a poll, which is simple random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay is fair? Of the 1,016 adult Americans surveyed, 558 said yes. We're going to get a 95% confidence interval for the proportion of adults who believe the amount of federal income tax they pay is fair. Okay, the first thing I'm going to do is calculate the p hat. So p hat is 558 divided by 1016. .55 is what I'm going with, because it's 0.5492, so I went to 0.55. Now, I'm not going to do the whole NP times 1 minus P is greater than or equal to 10. It is, and I just don't want to waste my space. Plus, 1,016 is definitely less than 5% of Americans that are 18 or older. So we're just going to agree that those things are true, and we're going to move on. I'm going to calculate the margin of error by itself. I like to do it that way because I would want to be able to write it both ways. So I'm going to calculate the margin of error by itself. Remember, the margin of error is the critical value times the new standard deviation. So let's look at our Z table, which is not there, which is over here. Somewhere over here. Okay. So my Z table, I have a 95% confidence interval is 1.96. So if we go back here, my alpha, it's a 95% confidence level. It's 100% minus 95%. So my alpha is 0.05. Remember that we cut that in half before we find our critical value. We're going to do it with the calculator, just so you're in the practice. So for my Z score, I'm going to put into the calculator. So my alpha divided by 2 is 0.025. Therefore, I'm going to put 0.975 into my calculator for inverse norm. If you want to use 0.025, you can, but make sure you just change it to positive. Okay, Let's do that. I'm going to do inverse norm. Oops, I hit the wrong button. So 0.975. That's not a 975. 0.975. There we go. So I got the same thing they did. They had 1.96. Just want to make sure we get the same thing and want to practice with that inverse norm. All right. So my z-score, my z, alpha divided by 2 is 1.96. All right, let's calculate our margin of error. So I take this z-score and I'm going to multiply it by the square root of my p hat times 1 minus the p hat divided by the sample size. This will give me the margin of error. I'm going to write those words there. So go ahead and put the whole thing in your calculator, being really careful with parentheses. If you aren't comfortable with parentheses, do it little piece by piece. I like to walk on the wild side and just use lots of parentheses. See if you and I get the same thing. How'd we do?
Yes.
Yay! Okay, so our margin of error is about 3%. So there's two different ways that we can write this depending on how my open math is asking us to write it or me on a test. So you could either say it is 0.55 plus or minus 0.03. That's one way. The other way that we could write it is 0.52 to 0.58. And they will ask for parentheses if you're putting it in interval notation. That seems to be the most common error when people are putting it into my open math, is it needs to have those parentheses for interval notation. So either one of these ways is perfectly fine. Questions before I show you calculator functions?
It has to be parentheses and like not brackets or anything.
I believe it needs to be parentheses. I think my open math is pretty picky about that. So, I mean, I personally like curly brackets, and I like
Who
regular,
doesn't?
you know.
I have a quick question. When you entered it on the, what's it called? On the calculator with the inverse
Yes,
one, you put 0.975.
yes.
How did you get that number?
Because 0.975 is 100% minus 2.5%.
Oh, that's right, thanks.
Yes. If you put it, you can put in the 0.025. You just have to remember to change it to positive. Because you're going to get a negative z-score. You just need to remember to change it to positive if you're not comfortable, with the other numbers. So just put in 0.025 and then just change it to positive. Okay, we have a calculator function. It's one prop z interval. One proportion z interval, that's what it's called. And we're going to put all of this into the calculator and we're going to get our lovely confidence interval. So one prop z interval, you're going to hit the stat button and over to tests. So once again, stat button, go over to tests. And you got to go down a little ways. One proportion z interval is letter A. One prop z int, letter A. And hit enter. Our X is the number of successes we have. which we had 558 people said yes. The N is your sample size. That was 1,016. Our confidence level is 95%. That's already there on mine. I want to give you a second so you can enter that into your calculator. What it's going to give you is the interval. If you need the margin of error, you're going to have to calculate that yourself. So there we are right there. And it is slightly different because it doesn't round like we did, but it still rounds to 0.52 and 0.58. This up here at the top is the interval, and it gives you the p hat right there and the sample size right there. So if they gave you these numbers, I'm going to write this down on my other screen so that I can show you how we would. I mean, some people, it's just pretty intuitive and you'd be like, oh yeah, I can calculate that margin of error, but it doesn't come easy to everyone. So I'm just going to do it for you. Okay. Let's go to my other screen. All right. So if I have an interval like this, and I want this written as p hat plus or minus margin of error, that I want it in that form. I know that p hat is smack dab in the middle of those two values. Or going back here, back to the other screen, it gives me my p hat right here. It gives me p hat. But if we were on, let's say we were on the MyOpen Math, they might just give you this confidence interval right here. So we're going to pretend we don't already know p hat. All right. So I'm going to take those two numbers, add them together. I'm going to round them. I'm going to do 0.52 plus 0.58, and then you divide it by 2. That number that you get will be your confidence interval, or sorry, will be your p hat. Make sure you put parentheses if you put this all in your calculator at 1. This gives me 0.55, which is my p hat. So that's right here. The margin of error at this point is pretty simple. You just take that 0.58, take the top of your interval and subtract the 0.55, and that's going to give you 0.03, and that's your margin of error. And during class, in your brain, you're like, well, duh, this is easy. But as soon as you get in the homework, that's when our brain decides it doesn't want to work anymore. So I wanted to show it to you just in case you get into the homework and your brain shuts off. We've all had that happen, right? Where we're like in class, yeah, this is easy. I got this. And as soon as you start doing the homework, your brain's like, no, I don't. I'm not doing this. Homie, don't play that. Happens all the time. All right, questions before we move on?
Could you go back to the other screen so I could see which selection? It was one prop Z int.
Yes, one prop Z int.
That's okay.
So it's test, hit stat.
It's stat.
Go over to
test.
tests.
Yeah.
So over to tests and then down to letter A.
Yeah.
One prop Z, one proportion Z interval is what it stands for.
Mine has X, N, and C level as the
Yeah.
what?
Yeah.
That's all the same. So
Your
so
X
so-
is the number of successes.
okay.
The N is your sample size. And C level is your confidence level. Make sure you put it as a decimal and don't put like 95 for 95%. Put 0.95.
Homie, don't play that. That's a in living color reference.
In color.
Wow. Wow. You got that.
Stock full of quarters.
You know, funny because I'll say that in a high school class and they all just look at me like,
Oh no, yeah, there's no
Yeah.
there's, I have one girl,
unless
though,
they're cool.
one of my geometry classes, she gets almost every weird, obscure reference that I use, which it didn't used to be obscure, but now it is. The homie don't play that. That's now obscure. It didn't used to be. Used to be pretty popular. All right. Okay, let's go back to our other screen. One prop Z interval saves you a lot of work, even though, I don't know, there's some sort kind of elegance calculating it yourself. I don't know why, it makes me happy. I'm weird. We knew that though. Okay, so this is it. It's just putting it on a nice piece of paper all by itself, calculating the margin of error. And it is just the critical value multiplied by the new standard deviation. That's it. That's all we got there. Okay. Now, suppose we want to do a confidence interval and we want to be 95% sure, and we want a specific margin of error. I want like a 2.5% margin of error. You want a specific margin of error. You want a specific level of confidence. We have to use a sample size that will work in order to give us that. So, because our standard deviation is dependent on n, and our p hat is dependent on n, we have to get fancy in order to find n, because we don't know p hat if we don't have n, right? Because p hat is successes over our sample size. So this is your formula, but I'm going to tell you the trick with this. So as the next ones tell me, okay, yeah, these are the two possible ways that we can solve this. Number one, if you find an earlier study that has already studied this, you can use their p hat. Or if you don't find an earlier study, if there's no earlier study, then we're going to let p hat be 0.5, because 0.5 is going to give us our largest possible value. So we have to, err on the side of caution here if we don't have a previous study. So these are the two options, and you will see in the assignment both of these cases. And I'm going to do examples for both of them. So let's math this out. This is our formula once again. And yeah, where p hat is our prior estimate. Now, important here. This is the important piece on this page right here. I can't have a sample size of 165.8. I just can't. I can't ask 0.8 of a person. Now, a sample size of, I just forgot the number I said, sample size of 106, if I was looking at 161.8 is what I got. 161 is too small. We always round up. Even if I got 161.1, we always round up. For sample sizes, always round up. If I didn't say it before, always round up. There you go. So don't say I didn't warn you. We always round up. Let's do some examples. Okay, this is if we don't have a prior estimate. 0.5 times 1 minus 0.5, which is 0.5, gives me this. You don't have to remember that. If you want to just multiply 0.5 times 1 minus 0.5, you can. But we're just simplifying it. All right, let's do this. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should we obtain if we want our estimate to be within 3 percentage points and a 90% confidence interval? There was a previous estimate from 2000 census that gave 82.4%. So there's our prior estimate. This is going to be the p hat that we are going to use. So here's the math. So our margin of error is going to be 0.03. We're looking at a 90% confidence interval. So we needed to put 0.95 in our calculator or look at our table. So take a look at 90%, 1.645. So that's my Z value, my Z sub alpha divided by 2. We're using the prior estimate. Therefore, we're going to use the 0.824. So here's the math. I take P hat times 1 minus P hat. That's right here. This right here is my Z sub alpha divided by 2. This right here is my margin of error. Don't forget to square it. So it says that I need 436.04 people. Always round up. Always round up. Yep, 4 to 37. I think of it like if I'm taking a bunch of kids to, let's say I'm taking a bunch of kids to Family Fun Center, and each bus holds 50 kids, and I have 162 kids, I still need that 4th bus. I can't just go with 3 buses and squish those 12 kids in. I mean, I guess technically you could, but we got to get the 4th bus. So we can't just squish it down. 436 wouldn't be enough. So always round up. So we're going to do one with the prior estimate and without. We're going to do one by hand. It's a lot. For some reason, I learn better when it's written out as it's talked through. An economist wants to know if the proportion of US population who commutes to work via carpooling is on the rise. We want to know what size sample we should obtain if we want an estimate within 2 percentage points with a 90% confidence interval. And we estimate 10% from a previous survey. So our prior estimate, our P hat is going to be 0.1. Once again, 90% back here gives me 1.645. That's my Z. I'm going to write that right down here. Z sub alpha divided by 2, 1.645. Therefore, our N, our sample size is going to be 0.1 times 1 minus 0.1 times the Z-score of 1.645 divided by the margin of error of 0.02 squared. So 0.1 times 1 minus 0.1 times the Z-score over the margin of error, and then square that. Let's put this in our calculators and see how we do. Give me a second. I happen to have pretty fast calculator hands. I got 608.86. Therefore, 607 people. How'd you do?
Maybe
Wait, wouldn't you round up?
Always.
Can
Oh, I don't know why I did that. I don't know why I did that. And you know what? The thing is you wouldn't even have rounded down if you were rounding normal. 609. There you go. Thank you. Did you get that answer?
could you show me how you entered that into the calculator?
All right. If you just watch, I'm going to get a different answer this time. So
Uh-oh.
I don't know. You never know with me. Let me get out of here. Okay. So I did 0.1 times 0.9. This is how I did it. Parenthesis 1, let's see, 0.645 divided by 0.02, closed my parentheses, and hit X squared. Enter.
Thank you.
You see where you went wrong?
Yeah. X squared.
Yeah. calculator typos are the bane of my existence. I do them so frequently. All right. Anyone else have questions before we do the last piece? Right, so it says, what if the economist didn't use any prior estimate? So I'm going to write 609 up here because I want you to see how big of a difference it is and how important prior estimates are. So let's erase all of this stuff down here. Okay, so without using a prior estimate, we use 0.5. So 0.5. If you want to just do 0.25, you're good. Go for it. 1.645 divided by 0.02 squared. Go ahead and enter that into your calculator. This is if there's no prior estimate. There's no prior estimate, you use 0.5 times 0.5. And give you a minute. How'd we do?
I get the same thing for sure. So,
Woohoo!
but you always use 0.5 if you don't have a pre-existing.
You could do 0.25 if you want. You don't have to do 0.5 times 0.5. You could have just entered it. Whoops, it's like this.
And I see that there's like two numbers that have the percent behind it. So like the 2% and then the 10%, but because the 2% says the sample something, I forgot what it says.
Okay.
We know that's the number you use on the bottom, right?
Okay, so this says that we want an estimate within 2 percentage points. So the within 2 percentage points, that part right there is telling me that that's my margin of error. Because I want my confidence interval to be within 2 percentage points. That's my margin of error. And the 10% is a previous estimate, 'cause it tells me I'm using a 2009 estimate of 10%. So that's where
Thank
that came from. You're welcome. But whatever the margin of error is, when it says within a certain number of percentage points, that's always the denominator. Other questions? How are we feeling? Okay?
Not great.
Not great? I mean,
Not great.
I could try to make one up if you want me to try to do that, to do another one of these.
Mm. Well, maybe you can answer this. If our homework will deal with the 90 and the 90%, so at least there's a little comfort there, or
It might choose a different value. The homework quite possibly could choose something else.
okay.
So for example, it could give you an 85% confidence interval.
Uh-huh.
And that's not one of ours on our sheet. So if it did an 80% confidence interval, you would do, or at 85%, as I always said, so you would do 1 minus 0.85, which is going to give you 0.15. Then you would just take the 0.15 and divide it in half, because we're looking at that middle 85%. This gives you 0. I get picked a bad one. So wait. Half of 15 is 7.5. Man. So this right here would be my alpha divided by 2 right there. This is the number you're going to use. And this right here is my alpha. This is the number you're going to use to find your, to find the critical value. Now, you don't have to get the upper one. You don't have to do 92.5. If I use, let me do it really quick here. Maybe if my calculator, I can do inverse norm with that number. Man, why is it taking so long to get there? 0.075. I could use the 0.075, but it's going to give me a negative z-score. You're just going to have to remember, use the positive.
Mhm. Okay.
So if you can remember that and put that in your knower and remember that, you should be fine. I know
You
I
use inverse norm. Can I write that down real quick?
Yes.
There we go.
see you all just start getting used to my weirdness and then the term's almost over.
Melissa, would you would you make up another problem just because?
Make something up. I can
Yes,
totally make
please.
something up.
Yes,
Okay.
please.
Thank
Okay,
you.
let me think here. What do we want to do? I mean, so let's do dog owners because my dog's going to be put down on the 13th, so or the 12th, so everything's about my dog right now.
Aw.
Not
so
trying to
sad.
make this all dark, sorry, but he's old, he's lived a long life, and so I'm trying not, but everything's about dogs right now. So let's say we're trying to we want to obtain a confidence interval that is accurate within, I'm going to say 4%, just because I want to do within 4%, to determine the number of homes that have dogs. Okay. I'm going to get, I want a 90. Do we want to choose something on our sheet or do we want to choose something not on our sheet?
On.
Yeah,
So
on.
on our sheet,
No.
that was a not on. Okay.
No.
Okay. So let's say this is going to be a really, really random one. Let's say 82%. I want to be 82% confidence interval. I don't know why I chose this. It's just what I did. So I want an 82% confidence interval, and I have a prior study that shows that 48% of households own dogs. So we're going to use these to calculate our confidence interval, or to determine the sample size, to find sample size. And these are all made up numbers. So I really don't know how many people own dogs. I just making up numbers. All right. You guys want me to give you an opportunity to do this and I'll wait a minute?
Yes, please.
Okay. I will wait a minute or two and then I'll work quietly behind you. Uh-oh. ahead and look up whenever you're done. See how you did.
And then can you put that in the calculator too with the inverse?
Yeah.
Thanks.
My Chrome decided to shut down, so it's going to give me take a second for me to get back there. I knew it was going to happen. I just had a feeling. Yeah. Open it here instead. My goodness. It'll take several seconds to refresh. Thinking about it. Maybe. Yay, there's my calculator. All right. So for the inverse norm, do second vars, inverse norm. Oops, that's the wrong button. So I used 0. I use 0.82. So so it's 18. So I'd do 0.09 because half of 18 is 9. Then 0 and 1. And then I just need to know that it's positive. So I got 1.3407, yada, yada. I hardly ever do the subtracting it from 100. I usually just get the negative. All right, so that was my Z sub alpha divided by 2. How did we do?
Got it. Thank you.
You're welcome.
I
This is
got it,
fun.
but I only figured out the first part of the problem and then I realized there's the second part. So now I understand both parts. Thank you.
We're good now? See, sometimes making them up off the top of my head's helpful. All right, so that was the last slide. That was a little bit of it. Hopefully that gave you enough to do section 9.1. As always, I'll answer your questions, messages, and things. I try to get to them as quickly as I can. So even though my syllabus says 24 hours, I try to get to them as quickly as I can. Once I have grandbabies with me, sometimes it takes a little longer. So any other questions while we are on recording? All right, I'm gonna get off the recording.